Optical networks. This chart gives a representation of just how much activity happens on the internet. For example, there are almost 3 million YouTube views and over 500,000 photos being shared on Snapchat every minute. An increase in personal, corporate, and machine-to-machine use will continue to drive demand, creating more and more internet traffic. Cisco estimates that by the end of 2016, annual global traffic will exceed 1 zettabyte, or 1 billion terabytes, or 400 trillion books. It is projected to grow exponentially, reaching an annual global traffic of 2.3 zettabytes by 2020. This is a 40% increase in demand every year. If we fail to improve our ability to supply data, then the internet will be a major limiting factor on progress and innovation. If new technology is not developed to increase capacity in optical fibers, then both growth within industries and economic growth as a whole will be stunted. Hence, what these industries and economies require is faster internet. In other words, an increase in bandwidth in optical fibers. What are optical fibers and what is bandwidth? Optical fibers are thin glass rods which use light to transmit data instead of the more traditional electrical cables. Current methods of using optical fibers are reaching their limits. To meet the increase in demand, researchers will have to push the frontiers of possibility with optic fibers. Bandwidth is defined as the amount of data that can be transmitted in a fixed amount of time. Improving the capacity of optic fibers will increase bandwidth, or in other words, will allow us to send more information through a fiber per second. So what's the solution? It is to transmit multiple streams of data through each optical fiber at the same time. This is known as multimode optical fiber and is achieved through multiplexing. Multiplexing means combining signals with different characteristics for transmission, then separating them out at their destination. Current research is combining 4 types of multiplexing: spatial multiplexing, wavelength division multiplexing, polarization multiplexing, and multi-level modulation. Combining all these techniques will allow us to transmit more data in a single physical fiber. Spatial multiplexing refers to sending multiple light signals down the same fiber in slightly different positions by using a set of antennas at either end. Wavelength division multiplexing involves using different wavelengths of laser light to transmit multiple streams of data. Polarization multiplexing takes advantage of the fact that laser light is confined to one plane. Hence, multiple streams can occupy multiple planes and be distinguished from one another. Finally, multi-level modulation. Traditional optical fiber transmission may only transmit one bit of data, that is either on or off, in each light signal. By using multiple levels of signal, we can transmit several bits in parallel in each light signal. Faster internet will make us more productive, connected, healthy, and entertained. In addition, there are possible environmental benefits to using optical fibers. Optical fibers use less energy in comparison with copper cables and hence can reduce energy consumption, which could save hundreds of kilowatts of energy per year. In short, who does faster internet benefit? Everyone.